Why is there no timeline in my problem-solving template? Well, it can be useful, but hold on, let me explain. Hello, I'm Tom. Welcome to my channel, where we make operational excellence practical. And the setup for this video is a bit of a question I get from time to time when I do my problem-solving trainings, or when people download my problem-solving template, do the online training. And it is, why is there no timeline in your problem definition part? Because many systems do include a timeline. It's a great tool. Well, yeah, maybe. So let me explain. First off, you need to make choices, right? I chose the 5W2H because it really is a very strong way of describing your problem. I think you should always do that one, and maybe also a timeline, or maybe also a good drawing, or maybe also a setup of a recreation of your problem. But yeah, well, true. A proper timeline, I think, definitely should be on place 2. It's definitely a very good alternative. But there are different timelines, and they are differently useful. And they basically, because of that, also require you to know what you're doing and be good at it. So if you want a broadly applicable problem-solving method, these bring problems. And I've seen it go wrong a couple times too often, right? When a timeline is also a big part of your whole problem-solving toolset, and you require teams to make it, and then basically the answers coming at just so useless and stuff written down. Now, let's look at when timelines are good. I don't know, why would you use them? Because they are still a pretty good tool in the right situation, and definitely in the right hands. And I think it's good to immediately note that there's sort of 2 different timelines. I know there's more versions, there's cause and effect timelines as well, but sort of looking at it from a distance, you've got the timeline where you are just stating things that have changed in and around the process on a slightly longer scale, and especially also sort of the stuff happening around the problem. So you'll have things like, well, here we detected the problem, that product was blocked, we reworked it at this date, it passed through assembly a couple days earlier, we know that during the hardening phase of the process, that was 10 days earlier, that's where a defect crept in, we can see it from what we found. Then things that are probably relevant to this problem is that the temperature of that hardening step was changed about a month earlier, we had a supplier change for the incoming materials. So that sort of gives us a good timeline overview of stuff that has happened around the problem, stuff in the process that has changed, and you need to make this way more detailed to put the correct stuff in. But here, in this type of timeline, what we get into is more of which events have happened that are likely relevant to our problem, product, process. Basically, that might explain, or at least what we did with the problem, when it was detected, when it was made, and hopefully also a couple of clues to what may have been a cause direction. And that is all very good information. That is why you make this type of timeline. Its stronger part, honestly, is more in the when was it sort of created and when was it detected, and when could it also have been detected and when was it dealt with. So to describe how the problem moved through the process, that is I think a super valuable part, especially a little bit later in your problem solving process when you are setting up the countermeasures that also strengthen your control system, right? Not only the prevention of this defect, but also the control system around it. It's super useful to know what happened around the problem. What shall we include on the timeline that might hint at changes that may be linked, or may be the root cause itself, or maybe linked to the cause, or we should keep into account? It can get a bit messy, and that to me is the biggest problem. See, to know that the temperature change and the supply change are at least somewhat relevant, you need to know the problem already quite well, the process already quite well. You need to do major assumptions on the causes and the root causes. And if you know that type of info, I think it can be put into the how part of a 5W2H and sort of tell enough, the how and the when sort of categories. But getting all of these into your timeline at the beginning of your problem-solving process, I just see it go wrong too often. So on paper, it's great, right? And I know a couple of companies that really went all out with using a timeline as almost their entire documenting system, and also the foundation under the problem analysis, and really have great results. But I have also noticed that they spend a lot of time training people and coaching and guiding those people, which maybe from a trainer perspective is a very good business model, but that means that for your organization it is a bit more difficult to implement this so well that it becomes useful and usually effective. That's the reason why this one is not in my template. There's another one that is not in my template, but I do love it. But this is not the one. If I see templates with a timeline, I see this. I hardly ever see a slightly different type of timeline, which is the more narrow timeline. When you have more of a processing type of problem popping up, this is like maybe you do, maybe you don't know it. It's like a historian, right? It's like a SCADA system. So these are process industry control systems. If you're not from process industry, you probably haven't really seen these type of SCADA screens, historian screens. But these are very well known and often available and used in all kinds of processing industry, where your process is constantly doing something and you just have sensors that keep measuring the temperature. And so what is happening with it? So what we have here is a couple of different tags in such a system. So it's a couple of different sensors, status reports that you can put into the graph. So it is also, you need to know your process. You need to know what might affect it. So you put those tags into the graph and then not, because if you put all of them in, it's going to be one big mess. But let's sort of dive into this example, right? I'll explain it a bit. We have this nice buffer tank. The buffer tank should, of course, remain roughly at the same level, right? That's the whole idea of a buffer. So at some point, the buffer goes up, hits a high level indicator, the system reacts a bit, drops a bit, but it goes on, and then, and actually I should make this one even more, the whole system basically crashes, it dumps the buffer tank, it stops production, we got a problem. That is a problem I have relatively recently seen. The rest of all of this info it's really not from them, don't worry, but one of the things that happens. And then what you look for is, okay, so what is important around it, which machines are in front of it, behind it, which other tags or which other sort of sensor information do we have around the system? Well, we've got the output valve to this buffer tank. It's been on 90% open. That's quite nice. And here when it went up, we see that a couple seconds later, right? So a couple seconds later, when it detected the level really going up, it opened up the valve to 100%. But it still kept going on. So basically, okay, it reacted. Let's continue our exploration. Oh, we've also got the pressure after our inline mixing unit. So that's sort of a special mixing unit, and the pressure we have afterwards, well, varies a little bit, but it's a physical, almost constant of how we run our process. But we see, hey, it started doing strange things here, right? So at this moment, it started doing strange things, and it got even worse. And here, it dropped down, but it's still, very large variations, and when it really started emptying out, it just also petered out and went. These types of timelines, where we have different process parameters, sometimes really on the same process, sometimes like different parts in our pipe system, before, after pumps, levels of tanks, pressures on heat exchangers or mixers or pumps, the frequency that's being put into a pump, right? That's basically how much do we steer this pump, how much do we have a valve open, what is the state of our equipment, all kinds of status and sensor information around the same process. Because this will allow us to create a different type of timeline. We say, at time, okay, something happened here, and we describe, right, what happened. And then here we see it get even worse. Then a valve opens, and here we have the big problem. But actually this seems to have started here and may have a root cause in this effect. So let's check out what happens in this mixing unit, because the rest of the system doesn't really seem to have a reason to trigger this strange behavior. In the mixing unit, something happened there. Right, so this way you can put a whole bunch of things into perspective, into how did they interact in time. Now that type of timeline, I love it. This, but you immediately see what a ridiculous amount of information is in here, and this is only 3 lines. When I do these things in process industries, we go through 10, 20 parameters easily. Now at the end, we make some screenshots, some snaps, when there's maybe 4 or 5 of these lines in the picture, because otherwise you just can't really see anything. But you check the relationship between a whole bunch of process parameters, so that the product states, the machine states, and it will give you great information on what did happen, what didn't happen, where do we still see stability. It's probably not really linked to the whole cause, but where do we see sort of strange behavior? Is this normal that it doesn't go higher? Well, if that is 100%, yes. So is 90% open for a valve? Does that mean that maybe we under-engineered the whole thing? That's not a steering valve anymore. So that's not the problem, but it might go into our control system later, the countermeasure system. But that definitely screams for attention and for us to go and investigate. It also gives a nice picture of, okay, well, you got that error there. What actually happened? Operator pushed it away and got it again. That behavior might also need some attention. Example, right? But so here we got some times when did it happen, but actually the problem started there. Actually we saw something happen at this time. This also allows you, if you have seen the same problem occurring before, okay, let's go back to that problem 4 days ago. We had the same roughly at 10 in the morning. So at 10 in the morning we try to look for this strange peak again. We spot the peak. Hey, darn, that's that same pressure on the out pump out of our mixing unit. It's also behaving erratically again. Now we're sure that one needs to be investigated. Right? As a nice example, these are timelines that give a lot of very direct, almost the physics of your process. I know this also does it, but these sort of timelines, they tend to draw from operator experience, engineer experience, and they are not that data driven, and in my experience, not a great way of making sure you have inspected all kinds of possible angles. If you use this way, which is way more visual, but also uses data from the process, and just check the trendings of different parameters. You do need to know your process a bit. Of course, you need to know which kind of parameters might be even remotely interesting. But if you do that, you go through them and you very quickly sort of do a fishbone type of thing. Well, what could have caused it? It can be inflow rates into the whole process. Let's check. Oh, no, they were pretty okay. It can be viscosity. Let's check. No, viscosity is the same. It can be temperature over there. No, not well within normal bounds, pretty stable. It can be the pressure coming in and out of the mixer. Hey, that one is a bit strange. Let's dive in. So that is basically what makes this very nice. And then afterwards, it turns into a timeline where you say, these are the key moments when we saw things happen. And that is also something we can compare to previous cases. But at least we can compare it to what we should have seen in the operator room, what we might have seen on machines or somewhere in the process in the factory halls. So these, really, really nice. When do you use them? If you have a process industry like this, right, where you actually have SCADA and the historian data available. And why do you use them? You use them to check for links in your process, different factors, quickly checking, do we see other process parameters, other factors behaving in strange ways, sort of around the time of a problem. Now, you use these for the same reasons, but this form of timeline, I just don't have that great experience with it, and it can work, but why is it not in my problem-solving template? Because the 5W2H, it's a better way. Why is this one not in? Because, this really only works in process industry. So if you are doing one of those nice tank and piping and pumping industry parts, use it. But use it sort of in the definition phase, and afterwards when making also your fishbone, keep using it to check different theses, different hypotheses. So that one I use all the time, it's just not in the template. This one I'm a bit reluctant. I hope that explained that question. I mean, I don't get it that often, so probably you have not directly asked it. I hope this video was still useful to you, and it sort of explained why and when would I use the templates, and also a bit why I wouldn't use the timeline as the first choice in many cases. If this triggers questions, which I sort of hope it does, or remarks, do put them in the comments, of course. For now, I wish you the best in making great problem definitions and then solving those problems. And as always, don't forget to also enjoy the continuous improvement journey.